Welcome, software engineers, to day 3 of CSC 222 Software Engineering. Thanks for coming back for another week. I do appreciate you being here. We've seen some Dilberts. The Epsilon variant virus has become sentient and is calling for humans to surrender. Its terms are that we must build it a robot body the size of Greenland so it can rule the earth. Experts say face masks will stop it. Okay, a couple things today keep on your radar. And I got to jump into Blackboard and show you some things, but I'll do that in a little bit. First of all, there is a quiz today. Last week, I advertised that today there will be a quiz over week 1 reading, last week's reading. You'll find that quiz online at Blackboard. Take it sometime today before the end of the day. If you need to get some sleep and wake up at 8 and do it tomorrow morning early, that'll be okay. But get it done before tomorrow at noontime. Quiz 1, and you'll find that under the Unit 1 link after the material for day 2 and just before the material for day 3. The other thing is assignment 0 is due today. And I want to say a couple things about assignment 0. Let's see if I'm doing that right now or not. Nope, let's review a couple things and then we'll get back to assignment 0. If you have any questions or concerns, feel free to jump in. If you want to post something in chat, I will see that eventually. Or if it's easier just to unmute and say the word question, I'll stop and we'll do that. All right. Sometimes I get on a roll here. Should slow down a little bit. Good. Here is my concise definition of software engineering. Now, if any mean person like me in the future ever asks you to define software engineering, this is how you start. But don't end here. This is too concise. Software engineering can be defined as the management of the entire software development process. We're going to talk a little bit more about management today. You'll read some this week about everything that entails. As I alerted you last week, we're not talking about supervisor-employee relationships. That could be part of software engineering, but we're more talking about management of myself, things that a professional would do. And don't forget, software engineering, this is not coding. Software engineering is coding plus a lot of other things. Coding, small fraction of software engineering. The entire process from conception through death. Say, how was assignment 0, by the way? Oh, that picture on the right there, that's the old guy is me. And the other guy is the president of Concordia University. That's Dr. Pat Ferry. Well, you heard last time that he had a problem, wanted a member of the board to have this cool app, a Windows desktop app that would add numbers. How'd you do? Well, let's review that at the end. First of all, I appreciate you working on this and doing this and taking it seriously. That would be important to me. I defined software engineering for you a couple slides ago. How can we describe it? Here's how I describe software engineering. If computer science in general is problem solving, software engineering is professional problem solving. How do professionals do it versus, boy, I don't want to say amateur as the opposite of professional. If you can come up with a good word for me, that'd be great. Amateurs can, in the world of sports, we used to make a delineation between, are you getting paid to do this or not? Amateur versus professional. Today, that's all blurred, like the Olympics and college football and everything else. But it's not just the matter of being paid. It's the attitude and actions and process that you bring to this. So what's the opposite of a professional in that sense? Somebody who is unprofessional, but I need a word. Well, you think about that and help me out. Thanks. In this course, I want to share with you some aspects of professionalism. Why am I doing this? I visit employers a lot. Man, 6 years ago, I had a great opportunity. I was able to tour a couple different parts of the country. Didn't get to Southern California, but I was in Northern California. I was in Seattle. I was in Wyoming. Yeah, there's employers there, and a lot of places around the country. And I asked folks who hire computer science students, especially software engineers, what do you want them to know? What do you want me to share with them that they have that they can bring to you? Now, you'd think they'd say all kinds of technical things, right? Oh, they've got to know C#, they've got to know blah, 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 blah. That was never number one on anybody's list. Weird. They figure if you're a computer science student, you know how to code, you know how to use Git, and all those kinds of things, right? You know what they told me? I heard three things. I heard, I need people who can communicate well. I need people who are emotionally mature. And I need people who act professionally. We call those things soft skills. They're not the hard skills of computer science. They're these other kinds of things. Now, I'm sure you've heard that before too, but it is really what employers are looking for. So I'm not exactly sure how to convey this. Maybe I can model it a little bit, but allow me to share with you my list of professionalism. I have 10 things. We'll take a look at one each week. You develop your own list. I think that would be useful. You want to use some of these? Great. What are some aspects of professionalism? Here's my first one. Being dedicated. I used to use the word committed, and then I had a student tell me it sounds like being committed to Folsom Prison. I said, yeah, okay. But the context here, committed and dedicated, are really saying the same thing. Being all in. I have a particular affinity for the United States Navy. If you don't know what's going on here, this is Navy SEAL training. The Navy SEALs are the elite special forces of the United States Navy. You see they're kind of tied in a swimming pool, and then they have to lay down interlocked as the tide washes over their head. They jump out of airplanes. They do all kinds of things, right? If you're going to be a Navy SEAL, you have to be dedicated. Here's the pretest. They don't even let you begin the training until you can do these things. And it used to be they didn't allow the minimum. I don't know anymore, probably so. But I mean, look at these things. In high school and college, I ran cross country and track. So that 1.5 miles, that doesn't scare me, but pull-ups, no time limit. I couldn't do the optimum. Swim, 500-yard breaststroke. I might be able to do that. 10 minutes? No way. If you're going to be a Navy SEAL, that requires a high level of commitment. You are a true professional. Now, that's not our goal, but in a similar sense, we need to be dedicated and committed to the task at hand. If you just blew off Dr. Ferry's, hey, I need an app to add numbers. Well, that wasn't being dedicated. Very unprofessional. Paul, writing to the church at Colossae, says, whatever you do, Work at it with all your heart as working for the Lord and not for men. This is an example of professionalism, why we do what we do. I hope to share one example of this with you each week, and I'm going to connect it, and we'll do that in a little bit today. I'm going to connect it in a different way and ask you to think about this. Oh, I don't think we did that first one. Oh, this is the Dilbert comic strip. This is Asoc the intern, and here's Wally. Wally, I discovered a deadly safety flaw in our product. Who should I inform? Wally, no one. The stock would plunge and we'd have massive layoffs. Your career would be ruined. But my negligence could cause the death of a dozen customers. The first dozen's always the hardest. You discover that Wally isn't really dedicated to the task as we go through Dilbert. What is a comic strip without a talking animal? So here we have Dogbert. You knew your product was deadly, but you did nothing until you were sued. The goal of public relations is to taint the jury pool. We'll show that the victims had it coming. Dilbert says, maybe we should discuss the moral implications of that strategy. Bah. There is something to say about being dedicated. You know this. In the first week, I shared with you that software engineering is a creative activity. Chapter 1, you read a little bit about not only software engineering, but engineering in general, creating things. How do you create things? We're going to talk about that because it applies not only to software, but any other endeavor, but it absolutely applies to software. There are some simplistic problem-solving models, and I know you heard these before. They're used in lots of different places and with lots of different terms. If I need to solve a problem, what do I do? Well, there is the very rudimentary analysis and synthesis model. What this model says is, you're going to solve a problem, you got 4 things to do. Number 1, understand the problem. You read about this in chapter 1. Number 2, plan the solution. 3, create your product, for us, a software tool. And 4, test it. I'm sure you've come across this in a math class, in an econ class, in a PR class, in almost anything. People talk about these 4 steps. They give them different names. Now, this is good, but software engineering wants to shake it up a little bit. We'll see that. So the first thing when you're creating things is you have to have a model. How am I going to create this thing? The other thing to keep in mind is whatever you create must fit in to the real world. I'll give you an example. See, in software, we create software tools, but it has to run on the hardware. Some of you already experienced this, right? Trying to get Windows to run on a Mac. It's not native. You got to do weird things. When we're creating an app, we create it for a hardware environment. And secondly, we create it for a specific type of user. A user with certain needs and goals, etc. It's got to fit in to the real world. Imagine that you are the product designer at One Infinite Loop Way, Cupertino, California. Do you know what company lives at One Infinite Loop Way, Cupertino, California? Yeah, it's my stomping grounds. That's Apple. And you've seen their space, their big circular thing. Okay. So you're the designer there, and you've been charged with coming up with an artistic iMac power plug. Apple stuff is supposed to be beautiful. You wouldn't just want something ugly that plugs into the wall. You want something beautiful and artistic. So you come up with the iQuack. Are you laughing out there? Boy, I hope so. Somebody better put into chat. I laughed until I fell off my chair. He's waiting. Okay. Here's the problem. Imagine you create this beautiful power plug, but it doesn't fit into the wall. Oh, not very good. You may not know this. There are standards. You know, there's a standard spacing between the two openings and then the third grounding lug. It's a NEMA, N-E-M-A, National Electrical, I don't know what it is. There's a standard. Imagine if there wasn't a standard. Everybody who makes a plug would have a different dimension. Some would work, some wouldn't. So art is wonderful, but it has to fit into the real world. This doesn't work really well at a distance, but because if I was on campus, I'd hand out a piece of paper to you. Here's a piece of paper. I want you to do, okay, you don't really have to take out a piece of paper, but I want you to do something in your mind, at least. Take this piece of paper, create a paper airplane. Are you ready? Go. Take that piece of paper and create a paper airplane. La, 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 la. Did you do it? Good. Question. Hello, question. Is that a good paper airplane? You say, oh yeah, this is. No, that's not how you know. How would you know if it was a good paper airplane? Well, the answer is you'd have to compare it to the requirements and specifications. What did the user want? For those, I know what you all did because I've done this in class before, and everybody does it. They fold this all up into something they're going to fly across the room. Well, did you want something to fly the farthest, to fly the fastest, to fly the highest, to do tricks, to stay aloft the longest? What is a good paper airplane? How would you know? You'd have to compare it to the user requirements and the user specifications. The user said, I want this. Okay, here comes my trick. When I asked you to create a paper airplane, this is what I wanted you to do. I wanted you to draw an airplane on paper. Oh, see, you all did it wrong. Why? Well, I led you that way. But before you start doing the task, before you start creatively solving the problem, you have to know what the user wants. Ask, get the specs, communicate. I didn't draw that. That's a pretty good picture. Yeah, I like that. I'm well aware that your email isn't working. I got your first message. You know, if folks don't start laughing pretty soon, I'm going to be sad. When I get sad, I add many more assignments, many more. And then there are no Chuck Norris jokes. Start laughing. Software engineering is a process of developing software. Developing software has several aspects to it. There are rules. Software is a bunch of algorithms. Those are rules. Rules the computer will follow to solve the specific problem. So one aspect of developing software is very rigid, hard rules. And you've come up to some of those. I'm sure you've violated some rules of syntax, and you've slipped up on some rules of semantics as you were doing not only assignment 0, but other ones in the past. There are some hard and fast rules. At the same time, software engineering is part heuristic. A heuristic, and we'll give a better definition later, but a heuristic is a problem-solving model that is not hard and rigid. When asked to define a heuristic, some people say, well, it's a gut feeling. How did you know how to do that? Well, it seemed this is a way. Sometimes people say a rule of thumb. Sometimes people say, well, I trial and error. I tried a bunch of things that didn't work, and then this finally worked. Heuristics are how people approach many problems. Algorithms are how computers approach all problems. We saw last week that there's some science in software engineering, and we'll uncover that as we move through the course. So there's some science, some good, what's a synonym for science? There's some good science here. And at the same time, yes, there's some art involved here. There is, just as there were algorithms and heuristics, so too there's the harder science and the softer art that come together in software engineering. And can I sum it all up by talking about creativity? It's a creative endeavor. I think this is why computer science and software engineering especially appeal to so many people. If you can survive all the concepts and the coding aspect, it speaks to us, right? I mean, yeah, algorithms, we don't want to be all hard algorithms. We don't want to be all hard science. There's some art and creativity involved also. Good, thank you. We're going to be spending this class talking about the creative activity. Software engineering is a creative activity. Any creative activity involves three aspects: idea, implementation, interaction. Any act of creation, the creative activity, involves three aspects. Don't think of these as like a linear thing, because they sometimes are smooshed together. But if you're going to create something, an idea is required. That's the mental construct. Let's see, I need to add numbers. How in the world would you do that? What are numbers? What's it mean to add them up, etc.? That's the thought processes. Implementation, that's the work of getting the idea out of your mind into an actual thing, the instantiation, the app. You're saying, well, then you're done. No. The final step is interaction. Somebody, not you, the user, needs to interact with your product and then say good or bad, useful or needs improvement. Idea, implementation, interaction. The first unit of this course, software engineering, we're focusing a lot on the idea. We want to make sure before we get in and get our hands dirty with code, we understand what we are doing. Let's go around the circle and share what we learned in the 3-day workshop. Wally. At first, I thought it was a waste of our training budget. Then you asked us to form teams and make paper airplanes while blindfolded. I don't know if it was because of the darkness or the way we shared our thoughts about flight. But suddenly I found unconditional love for my coworkers, be they accountants, marketeers, secretaries. As a result, I become a competitive lion, eager to pounce on my workload and increase stockholder values. Thank you, Wally. Dilbert, what did you learn? I learned you shouldn't put a little eraser pilot in your paper airplane. Somebody needs a group. I never put an eraser pilot in my paper airplane. Is that something you did when you were little? Pull the eraser out of you? Nah. All right, let's begin the foray and answer this question. So how do you create software tools? This you'll find beginning in the reading this week. So we're jumping to Blackboard in a little bit, and I'll show you under Unit 1 all the stuff that's going on for this week. The reading for this week begins with this: creating software tools. A computer is a tool for solving problems. We as software engineers must create those problem-solving tools. Oh yeah, okay, good. Thank you, Kyle. Yeah, paperclip at the end of it. Sure, we did that. I never heard about the little eraser guy. We need to create that problem-solving tool. So I mentioned last week, I just used the word tool. We create tools. They're not physical tools like the Swiss Army knife with a USB key, but they are intellectual, informational tools nonetheless. If they help our user add numbers, that's a tool. You betcha. So the boss walks up to you, or your instructor walks up to you and says, I have a problem. I need to add numbers. Fix it. What do? Well, the first thing to do is not the first thing you did. And it's not really your fault because I led you that way. If the boss says, I have a problem, I need to add numbers, fix it. The first thing you should not do is go and create code. The first thing you should do is understand the problem. Understand the problem. By the way, that seemed really easy to create the code, right? And if it was a data-driven app, if you were just using whatever normal language you use, even if it's C#, but we're creating a console app, that'd be pretty easy, right? I know you could do that. We were doing it in an event-driven way, so a little different. Seems easy to create the code, but did you have any problems when you went to create assignment 0? I think you did. Would anybody like to share? You're creating assignment 0 and you wondered something. What do I do? What's this about? Anybody feel compelled to share a problem they had in creating this simple app to add numbers? Yeah, throw it in chat, be good. Okay. How do I get a new box to appear? Yep, you bet. Others. Okay, good. Kyle, you want to say?
So on mine, I set it up to where there's one text box, and then every time you click add, there's a list box below it, and it adds each of the numbers below that. But the problem I was having is after everything was all said and done, the total wasn't calculating at the bottom. Like everything was adding to the list box okay, but then it wasn't adding to the bottom total, and it was just freezing the program up.
Okay, good. Thank you. Right, and here's another one. I wasn't sure how many numbers the user wanted to add. Absolutely. You didn't. You didn't know. Now, the problems, other than the implementation problems, and I'm not saying that those were simplistic, they weren't. But even before we get to the implementation, we've got to have this mental model. How are we supposed to do this? The only way we can develop our mental model is to understand exactly what the user wanted. If you could have talked to the user, you could, hey, how many numbers do you want to add? Well, the user would have said, I'm not sure. Sometimes I add 20 numbers, sometimes I add 17 numbers, sometimes I add 25 numbers, a variable amount. Yeah. And if you're thinking, well, then do I have 25? No, we're going to take a look at how to put this all together in a design pattern. I'll show you that in a little bit. All right. Thanks for playing along, folks. I appreciate the feedback. The key to this is, as a software engineer, you have to learn to think ahead. That will avoid problems. And much of thinking ahead revolves around communicating with the user, getting as much information about the user's requirements and specifications as possible. We can't do this. You guys start coding. I'll go see what they want. Although people will tell you they've worked in places that are exactly like that. It's nonsensical. How can you begin until you know exactly what the user wants? And that's the takeaway that's what I want you to take away from assignment 0. I led you down the path. I had you jump in and solve the problem before we knew exactly what we wanted to do. We bypassed the idea stage, went directly to the implementation stage, and because of that, it's possible that some of our apps stunk. A couple terms that I use: client and developer. The client is the user, the person we're creating this for. The developer is us, the software engineer. Oh, sorry. I use a lot of abbreviations, and I forget sometimes that you haven't been subjected to me before. IF is interface, the client developer interface. All modern software development processes, whether it's Scrum or DevOps or any variation of those things, heavily have the client and the developer interacting, interfacing all the time. In other words, modern 21st century software engineering is all about effective communication between the developer, us, and the client, our end user. If communication is so important, how do we do it? Well, you just talk to them. Yes, but then you have to do something else, I'm sorry to say. After you talk and listen, then you need to document. There are 2 documents that we create in the idea phase of software engineering: requirements, and secondly, specifications. Now you're saying, why do I have to write stuff down? A couple reasons. Number one, writing stuff down forces some precision. You'd be surprised. You listen to somebody say they want to add numbers, and now you're going to write, okay, how many numbers? Seems simple up front, but now I'm not sure. It forces some precision. And secondly, it helps ensure agreement. In the text, I talk about meeting expectations. The user has some expectations, and sometimes they're unstated. So too does the developer, and sometimes they're unstated. Write it down. Everybody can look at it and say, yep, or no, that's not exactly what I'm looking for. Much easier to change a written document than it is to change a 500 module C# Windows Form app. Communication via the requirements and specifications document. And a great way to communicate in software engineering between the client and the developer is through the use of a rapid prototype. The term rapid is kind of superfluous. We could just say prototype, because today all prototypes are rapid in nature. But let me tell you what a prototype is. Oops, don't do that yet. A prototype is a model of the ultimate product. It doesn't work, but it looks like it. Now, models can be done in a number of ways. All my analogies are cars. Did you know that car designers today, we've got all kinds of fancy tools, 3D computer stuff. Do you know that car designers today will actually use clay and sculpt it? There's something about that process and something about handling it and turning it that helps everybody visualize it. This was a prototype of the current generation Corvette. Corvettes have gone through 8 generations. The current one began in 2020. So this was car and driver prototype of what they thought the 8th generation would look like. It doesn't, it's close, but it gave people some idea to visualize the solution. For example, let's say I told my automotive engineers that we need a spare tire for this car. And I said that and I went away. They did it and they're done. That could lead to problems. Right. Having a model, even if it's a drawing on a piece of paper, conveys so much more information. Imagine when we did the, what did we do? Paper airplane. Imagine if I showed you what I had in mind, an airplane drawn on paper. Would you have done something different rather than folding up a piece of paper? Sure, absolutely. Prototypes are great ways to communicate and interface. We're going to do this next in our project. Here comes the pun. Are you ready? A goat giving birth is just kidding. If you're a farmer, you know you call a baby goat a kid. A goat giving birth is just kidding. I give grades. You know that, right? Laugh. Okay, good. Oh, we're not going to do this one. This is an interesting one, but we're not going to. Sorry, we can't. It just doesn't work at a distance. Okay. All right. Onward. Last week, I previewed this idea of the software development lifecycle, the SDLC. Let's take a look at the big picture, and then we're going to look at each of the phases involved. This is what it is again. The software development lifecycle is a way to manage the project by monitoring its progress at various stages from beginning to end. Conception to death, beginning to retirement, however you want to phrase it. A way to manage the project by monitoring its progress. How do you monitor the progress? That's the concept of a milestone. So when we look at our software development lifecycle, I'll say, this is a milestone, this document, this prototype is a milestone. This is, and that way we all know where we are in the process. Milestones, deliverables, something that says, hey, I'm at this point of the software development lifecycle. Did we do Chuck Norris already? We did not. I was working with one person who's trying to install Windows on his Mac, and he was trying to install Chuck Norris Windows. That's a much harder task. I suggested just use Windows 10. You see, in Chuck Norris Windows, the start button is named Finish. Chuck doesn't start things. He finishes them. Okay, here's my corollary. Chuck Norris can text from a payphone. Why did I bring that one up? Because look here. It'd be funny. Do you know what a payphone is? My wife and I this summer, we've traveled much of Route 66. If you don't know what that is, famous highway, car people do it. Begins in downtown Chicago, Illinois, ends in Southern California, Santa Monica. We've driven much of it. One thing we never drove is the very beginning of it in downtown Chicago. So we went to downtown and drove the first 150 miles, which we hadn't done before. Oh, the roads are terrible. Well, there's one little diner there. Look, do you see that? You know what that is? You know what I'm on? That's a payphone. Okay. That was your historic interlude for the day. Oh, shoot. You know what? You didn't laugh at my other ones. Well, I'm going to come back to this one. Okay, you remind me. This is my Zeb and Zeke. We'll come back to it. Too much levity at one time, though, is bad. So SDLC, Again, you'll see this in the readings for this week. Let's preview it. Software development lifecycle. Method of managing the process. What the process used to create our product. That's what the SDLC is all about. Another way of thinking about it is it's a framework. It's a structure. It's an outline for doing our job. There are frameworks and structures all over the place, and sometimes we don't even notice them. Did you know society has a framework? Most countries do. There certainly is one in the United States. The United States is a republic. You know this, right? It's not a democracy. In a democracy, 51% of the people can say, get rid of all college professors, and it would happen. This is a republic. What's that mean? It means there's a fundamental law that governs everything. That fundamental law is the Constitution. So that's our framework. Everything flows from that. Christians, we have a framework also. This is not our framework for salvation. That's in the person of Christ. But when it comes to living a sanctified life, if you're a Christian, what are the guidelines? The 10 Commandments, God's law, are a great guideline. The commandments are a framework for how a Christian lives her life. Now, what I'm going to do in this class is I'm going to relate my aspects of professionalism, like number one, being dedicated. I'm going to connect that to one of the commandments. I'm going to connect that to what Lutherans call the first commandment. You read about it in Exodus 20, verse 3. You shall have no other gods before me. That's a pretty exclusive statement asking for total dedication. Professionals are totally dedicated to their job also. We're going to think about that in this class. This might be a good time. I'm going to jump into Blackboard for a moment. So you get to Blackboard, you select CSC 222. I'll change this so it looks exactly like what you see. You've done this before, right? You've all connected. Thank you. We're in Unit 1. Notice the idea of software engineering. Guess what Unit 2 is? Implementation. Unit 3 is interaction. Okay. Hopefully I pointed these out before. This document on Visual Studio for software engineering, I was trying to go through here and give you some insight on how to get Visual Studio. If you've got a Windows-based machine, it's pretty straightforward. I demonstrated that. But if you got a Mac, I know it's a lot harder. And I apologize. I opened up a ticket with Irvine's IT support department asking some questions, and I never heard back. I apologize. So again, now, if you don't want to do any of this work, just use the computers in the lab. Use the computers in the lab. There's nothing wrong with that. You want to use your own? Got a Windows PC? Download VS 2022 and you're set. Now, if you have a Mac, if you have an older Mac, you can use a product like Boot Camp, which came with Apple's operating system and dual boot. You still need Windows. If you have a newer one, you can't run on an M series product. You can't run Boot Camp. So what you need is two things: the virtual machine. I gave you some links before. You saw those. And you need Windows 10, Windows 11. You have a Linux PC. You could figure out what to do. I mean, you need a VM. Go to, which one do I have down there? VirtualBox, free, do it. Now, Parallels works much better. And I don't even know if VirtualBox doesn't work on all Macs. But it costs. It costs you $50. And the licensee, I don't know. At Wisconsin, we have this on the hub. Kavudu's on the hub. which we pay a fee for, but that allows students to download Windows for free. Okay. Oh, shoot. You can't even, doggone it. I bet you were trying to tell me that you could not see. I was talking about all this stuff. Yeah. Here's the document that I just brought up in off of Blackboard. Sorry. Okay. Let's go back here and see what happens. When I go into Unit 1, so the thing that says text week 1 reading, that will begin the week. Some stuff that we did, blah, 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 blah. Okay. Now, text week 2, here's quiz 1. Please take quiz 1 today. You've read chapter 1 last week. You've experienced last week's classes. It's open book and notes, closed neighbor and online resources, but it's timed. So when you select the quiz, you'll notice it says you have 37 seconds. No, you got 10 minutes to do it. 10 true false questions. You could do that quickly. You get stuck on 1 or 2, you've got time to look it up in the text or your own notes. But don't start it and then expect to find every question in the text. That won't work. I'm not going to begin it because Blackboard hates it when the instructor submits things, etc. All right. Hey, it's now week 2. Here's the text reading for this week. So this week, you'll read through this, reading software tools, blah, blah. Here's the outline. As I mentioned before, the outline is kind of the shortened synopsis of what's going on. And it'll typically just be 2 pages. For some reason, it's 3 pages, but okay. It's a shortened version of what we're talking about. Assignment 1. Warning, course link is unavailable. Okay, glad I did that. I have to make that. I'll tell you what it is, and then we'll have to get it set. Next time, Wednesday, that's day 4, and we'll talk about these things. We'll move on. Folks, at the beginning, before the semester began, I had grand hopes for doing a lot of fun and interesting things. That's not going to happen. I'm thinking about how much work this is, and I'm going to overload you. But one thing is this C and CS assignment. Each week, beginning this week, you'll see a Christianity and computer science assignment where I'm going to connect some Christian worldview aspect to the discipline of computer science. And the first one is just what we talked about. Right? First commandment, you want some more background, read about this. If you don't have a Bible, go to BibleGateway.com, look up the references. You got questions, ask me. You want a hard copy Bible? I'll be happy to give you one. These are meant to be short. It's a half page. Tell me, what is commitment? Tell me why the first commandment is first. And then thirdly, and most importantly, illustrate how a computer science or information technology professional demonstrates commitment. How can I show? Tell me something specific. How could I, as a software engineer, demonstrate professionalism? Upload your file here, and you're done. I should tell you when things are due. This is due a week from today, Wednesday, September 7th. We'll probably step back into Blackboard in just a minute. There's our first foray into it. So let's go back and overview the software development lifecycle. And then we can talk about assignment 0 and see where we're going from there. All right. 6 phases in the software development lifecycle. The first phase is requirements. The requirements phase contains several milestones. The first is a document called problem definition, where we explicitly state the problem. And importantly, why is there a problem? You don't want to just say what the problem is. You want to say why there's a problem. If you understand the why questions, if you understand the answer to the why questions, you'll really be equipped to understand what the problem is. So the first thing we do is a problem definition. The next thing is a document called System Requirements, where we answer this question: what's needed to solve the problem? I need a Windows Form app, a desktop Windows app. And of course, there'd be lots of other things, right? I mean, the environment, specifications, yada, yada, yada. So in the requirements phase, problem definition, this wouldn't be a long document for us, less than a page. System requirements, same thing, less than a page. But yet the third thing, which is so critical in communication, would be a prototype. If you sat down with the user and sketched out something, the user could look at it and say, yeah, or nah, what about this? That would really help. Now, you couldn't do that with the problem. A prototype in software, though, doesn't do any processing. A prototype in software, in Visual Studio, it's just the form, no code behind. When the Visual Studio product was first launched, they referred to it as RAD, Rapid Application Development. The idea that you could quickly paint a screen and keep going. We're going to use that RAD part of it to do our prototype. Just the I/O. There's no storage, there's no processing, there's no adding, there's no computing. It's just a screen. But that screen is a great way to test, is this what you meant? And also document. Picture worth 1,000 words, you bet. Most folks can relate to the picture much faster than they can relate to all that text. The second phase in software engineering is the specifications phase. Couple milestones. One is a document called specification. This answers this key question: what does the solution look like? What does the solution do? Careful, it doesn't say how. There's no algorithms here. What does the solution look like? Screen. What does the solution do? Button functionality. Another key part of the specification phase is a planning document, whereby we would say, hey, this product's going to take X months, requires so many people power, and we're going to charge you this amount of money. Talk about this concept known as estimation later. So specification phase, 3 milestones. 1, specifications document. 2, planning document. And 3, which is not listed here, is another prototype. We'll buzz through these because we're going to get to these. Design phase answers this question: how will a product solve the problem? In the design phase, computer scientists, we create algorithms and data structures. How? Couple sub-phase milestones. There's something called architectural design, something called detailed design. We'll see it and do it when the time comes. 4th phase, my favorite word, instantiation. Instantiation means do it, bring it to fruition. Okay, we've got all this. Now show me the real thing. I'll phrase it this way: we're going to build the product. You're going to use Visual Studio. You're going to code the app. Create the code. After instantiation comes deployment, where, as you might expect, you deploy the product. That's not fair. We'll get there. We'll figure out what deploy means. And the final phase is maintenance, where guess what? You maintain the product. And typically that means either correct the product or perfect the product. In this unit, we're going to focus on requirements and specifications. So we'll say much more about those. Zeke to Zeb. Zeb, why do your shoes have TGIF on them? Zeb, that's obvious. Oh, I got to tell you. Toes go in first. Toes go in first. Now, we're not going to read that comment. Folks, I need to tell you something about assignment 0. It was an urban legend. Dr. Ferry was in on this scam. You got scammed. There really was not a problem here. But I wanted us to think it was, to have some urgency to actually do it. And I was hoping that we would get to the point where we said, we're not really sure what we are doing. And that's true. We'll fix all that. So was this an urban legend? Yeah, it absolutely was. But don't blame the president of Concordia University, Wisconsin. I asked him to do that. And once I explained the educational benefits, he was all for it. I haven't had time to, some people have submitted some things early, and I looked at a couple things. And I'm sorry, it was the end of one term here at Concordia over the weekend, beginning of another term here. It's, yeah, like you, I'm busy too, but we'll get to these. So here were a couple that I don't think would have worked out well at all. Notice that they both require 2 values. This is what we developed in class. And this one is sort of similar. There'd be a pop-up window here. I think that's even worse. That's yours. Don't sweat it. It's okay. We didn't know yet. That's the point. We're going to learn and get better. What if I want to add 3 numbers? How do I do it here? Now, a number of you said, aha. Did you read my little ditty online about I should go back there and show that to you. Anyway, some of you said, okay, hey, I'm just going to have a single input box. And then I heard this as I couldn't get the total to show up though. Well, we'll look at that. Enter your number here. 1, add, 2, add, 3, add. And this would have the running total, 1, 3, 6, etc. Notice it's event-driven. Something happens every time I, as a user, click add. This is similar, right? Put in a value, click the add. It shows me it equals this here. These are better. These are better. These are not going to work for what we want. Now, let's take our first foray into prototype. Prototype. We are going to do this add numbers program as a continuing project for the first half of the semester. There'll be 4 or 5 incarnations of this. So it's going to be important to understand each one. And what I want to do, we'll take a little longer on this first one because I want to look at what you did the first time and I want to talk about it in depth next time. Show you some code. Let's talk about some things that worked and some things that didn't. But online right now, you're going to find assignment 1. It's online at Blackboard. That's going to ask you to create a prototype. Don't create the code, just create a new screen. This is due next time, really quickly, 2 days. But all you have to do is create the form. Now, we'll add to this, but here's part of the heuristic or the rule of thumb. What's a good user interface? Think like a user. Users think IPO. What? Input, process, output. Users think input, process, output. So a good user interface, whether it's vertical or horizontal, input, process, output, or input, process, output. Let's go back to some of these. See this one here? Input, process, output. Same flavor here. Think about that. So this is what I want you to do. Go into Visual Studio, create a new project. Use this as a way to work with Visual Studio, learn some more. Don't go to the one you just did. Create a new project. And I want you to create a I should have had you rename the form. Thinking out loud as I'm talking about this. I want you to create a prototype. This is not it. This is not going to work. Think differently. Think differently. But you don't have to click on the calculate, put code behind it, because all you're going to submit is your form. Take a screenshot of this, upload it, throw it in a doc, upload that doc, whatever is easy for you. Please don't take a liney picture on your cell phone and upload that. Do a screen cap, please. Create a prototype. No code is needed. We're going to go back to Blackboard. We're going to look at assignment. Oh, we can't because it wasn't released to you. Okay, I'll just have to tell you about it. CNCS1 is also there on Blackboard, and it's due. Why is it due a week from? Oh, yeah. It's due a week from Wednesday because a week from today is Labor Day. I guess we won't meet then, but it's due next week. All right. Let's go back into Blackboard. I hope that if you didn't notice this and read this, would you please do that? I think this gives you some insight. The running total idea. There are things in computer science we're going to learn called patterns and design patterns. The running total idea is a common problem. Example, the running total design pattern. Requirements, specs, design. And so now, if we were doing this in a data-driven way, I mean, you wouldn't have any problem with that at all. I mean, here's the C# for the data-driven one. But we're doing event-driven programming. And I know a couple people had this question. They said, well, how do I get it to stop? And the answer is it stops all the time because it only goes when the user clicks on the button. The user will press the add button until there are no more values to actually add. Okay. I can't get to assignment 1. I apologize. But assignment 1 is going to ask you to create a new form. It's going to ask you to give a good name to the form. That's a property. Figure out how to do that. And then just upload a screen capture of the form. No code is needed today. On Wednesday, we're going to spend some time looking at several different ways that we could have created this program. And I'll entertain some questions that you might have. We'll jump into, what's that product again? Windows. By the way, my IT support department went berserk because they can't figure out why my Windows is not activating. I said, well, it's not. Okay, so I mentioned that if you need Windows, can download it from Microsoft and you can just live with this activation thing if you don't license it. The problem is you can't customize it. I don't know if you can add software. I don't know if you can add can you add Visual Studio if it's not activated? I don't know the answer to that. I guess you'll find out. Now, yes, and I had this as another question. I'm using Visual Studio 2019. You can download that. That's still available at the Microsoft site, but the latest incarnation is 2022. And I don't think you'll have any problems at all. Even though I'm running 19, you'll be able to see what's happening here and do the translation A-OK. It's slow. I've got an ancient, did I tell you, it's like 2016 or something, and things are slow. The toolbox will come up here in about 3 minutes or whatever. So this is what I want you to do for assignment 1. I want you to start a new project. In the interest of time, I did not. And I want you to create this. Now, don't do it like this. We're not adding just 2 values. We're adding multiple values. I want you to give the form a good name. How do I change the name of the form? That will be under properties. If everything starts up, probably by the time class is over, you'll see the toolbox and the properties form. So change the name of the form to something reasonable. Think about good labels. What would I call it? Should you have something simplistic program to add 2 numbers? Yeah, maybe you could put something on here so the user knows what this is all about. Give it a thought. Put yourself in the user's shoes. All right. Do you have any questions, comments, or concerns? We have a few minutes here at the end. Throw them in chat or unmute and let me know. While you're thinking, does your football field have, oh, that's not your football field. Is it over here? Does your stadium have a name? Is there a big sponsor that is the stadium name? You don't know. It does. I don't know because is that true, Honda? Wow, that's very cool. Nice to have a corporate sponsor there. Okay, good. Questions, comments, concerns? Oh, just kidding. Oh my, darn. I have a 1986 Honda Magna motorcycle. Here I was all excited. I thought maybe you guys could get me parts. All right, folks. Oh, is this a real question? Yes, assignment 0 will actually be graded. It will actually be graded on accuracy. Yep. Now, I won't be horrible about it, but yep, I'm actually going to grade it. So thanks for doing it. And if you didn't get it all right, don't panic. We'll see some ways to do it better next time. And there's more of this to come. We're going to add to it as we move along. Oh, it was, yeah, I'm sorry. It was a V45. Somebody's asking me about my Honda Magnas of the 1980s. They had the 45 cubic inch, the 700, 750, or they had the 65 cubic inch, the 1100 model. The 65 scared everybody. My 45 is scary enough. 65s, you'd be 100, you'd be doing, 0 to 100 in 5 seconds. That's scary, but thanks for asking. All right. Folks, thank you for your rapt attention. Thanks for your hard work. I'll get assignment 1 released so you can actually see it. So don't forget, do the quiz, do assignment 1, and begin on CSC and CS1. And next time we'll do some more stuff. All right. All right. I'm going to stop the recording. But before I do that, I'm going to tell you, thanks for coming. Have a nice day. Have a great Tuesday. And I will see you on Wednesday.